Moving on, we're going to look at parallelism. This means that two vectors have the same direction vector. We're going to learn more about this in A levels if you're planning to take them. But here you just have to know that if two vectors are parallel, then they are multiples of each other. So you have learned that 4 and 2 are multiples of each other, meaning 2 into 2 is 4. Or also we have like 6 and 18. If you multiply 3 into 6, we get 18. And therefore, parallel vectors in the chapter of vectors means that they are like scalar products of each other, if that makes sense. All right, so let's just look at this example. So we have A and then we have 2A. The multiplication of 2 is what is different, meaning the magnitude of this vector is twice that of just A. And therefore, parallel vectors have the same direction but different magnitude. But they can also have the same magnitude, but it's not a condition for vectors to be parallel. The only condition it has to meet is that they have the same direction vector, which in this case is A for all these three. And therefore the magnitude can be different, but the direction vector has to be the same. And we have AB. So if A is parallel to B, then there exists a scalar value of K such that A is KB. That's pretty simple. It's time to do some questions. Let's look at the first one. What can be deducted from the following? We have A is 3 times the vector CD. Like we saw in the previous slide, this means that there are parallel vectors because AB is essentially a product of a scalar value k and some other vector. And therefore, A means that they are parallel vectors. This is slightly interesting. This is because although this is a scalar product or like a scalar constant that is being multiplied to another vector, we know that if we have A, this is vector A, this will be negative A, just to know the direction. It's supposed to be parallel, but yeah. Let's say this. This is negative A because it's in the opposite direction. And this also applies here because there's a negative sign in front of this. It means that they're anti-parallel vectors, meaning they are parallel but they face the opposite direction, almost like couple in physics. So like we have this, one force acts upwards, the other one downwards, and therefore they form a couple. And this is similar, one acts this way and the other, maybe the magnitude might be different, so it doesn't matter. So these two are still parallel, but they are somewhat anti-parallel because they're in the opposite direction. And now this is the same thing as this. So yeah, they're parallel vectors. And now we can look at this. We have to find R given that A is this and B is this and that they're parallel. Okay. We have this, right? We know that they're parallel, meaning A is KB. This is the notation for a vector, or you can use like an arrow, or you can make the letters bold, whatever you want. So A is 2 minus 1 k into negative 6r. We can equate the top half of the equation, so it's 2 is minus 6k. And the value of k is negative 1 by 3. And now we know that negative 1 is k into r, and it implies that negative 1 is negative 1 divided by 3r. So if you want to find r, we multiply this here and divide by negative 1. we end up with 3. So therefore, the value of r is 3. This is also a very similar question. It's a equals k b. And now a is -1 r and k multiplied by 2 minus 3. -1 equals 2k, or k into 2, and we can deduct that k is -1 by 2. And if we want to find r is basically -1 by 2 into -3, which is basically 3 by 2. And that's how you solve a question like this. Okay, I think this is the last question. We have to find the vector v, which has the same direction as 2 minus 1 and length of 3 units. This basically is telling you that the magnitude is 3, and therefore we can say k multiplied by 2 minus 1. If we find the magnitude of this, which is basically square root of 2k whole squared plus -1k whole squared, is essentially 3. And therefore we can expand this. The first question is very simple, but it's gonna get complicated as you solve hard problems. So we have 2k whole squared plus, this is essentially plus 1 squared. So it's k squared, which is 9. We have 4k x squared plus k squared, which is 9. And this is going to be 5k squared equals 9. And k squared, square of k will be 9 by 5. And k will be plus or minus 3 root, 3 divided by root 5. Okay. So we have to find the vector v, right? And therefore it's going to be 3 root 5, 2, and this is going to be 3 root 5, negative 3 root 5, 3 by root 5. We can't write k as -1 because that means it's gonna go in the opposite direction. So therefore we have to reject the possibility of -3 by root 5. Therefore, this is our final answer. Here, I want you to try this out for yourself and see where you go. And here it's in the opposite direction, meaning here we have taken plus or minus, but here we have to do negative because it's going in the opposite direction, right? And therefore, it's going to have a very similar answer, but when you do square root of whatever you get, here, you have to take the negative value. And that's basically it. So we have reached the last topic here, which is unit vectors. This is pretty simple. There's not much in this. You just have to know the formula and why it's used. So a unit vector is often used to give you the direction. So if it's basically of magnitude 1 and it will show you the direction of the vector. That's why unit vectors are used. So given a non-zero vector A, its magnitude, which is modulus of A, is a scalar quantity. If we multiply A by the scalar 1 divided by the magnitude of the vector, we obtain a parallel vector with unit 1. Like I told you, we use this to show the direction of the vector. Since they are parallel vectors and magnitude doesn't matter, we're trying to indicate the direction of the vector. So a unit vector in the direction of A is 1 divided by the modulus of the vector multiplied by the vector. And a vector of length k in the same direction of A is k divided by the magnitude of A multiplied by the vector A. It's basically that. and they're parallel and they could be plus or minus. I told you, right? It can either be parallel or anti-parallel, meaning they act in the same like line, but they face like opposite directions. So that's what I mean by anti-parallel vectors. And that's it. I can give you an example also. If, for example, find the unit vector of, let's say, 3i minus 4j. What do? We have to, first of all, find the magnitude. No matter what, just find the magnitude. So let's say this is vector c. This is this. So the magnitude of c is going to be the square root of 3 squared plus 4 squared. That's 9 plus 16, which is 5. And therefore, the unit vector is 1 by 5 multiplied by 3 and then 3 minus 4. So that's basically it. That's how you find the unit vector. It's as simple as that. And with this, we're done with the whole vectors topic. And it's best if you go through this video. If you want to do it again, and then go to your textbook, solve all the questions, do some past papers, find questions. Like, I think it's online where you can like find topical questions where you can solve questions based on a particular chapter, and that will actually help you maximize your score. So all the best, and hope to see you in the next video.